everybody and welcome to your science lesson for today. Today we're going to be continuing our work on magnets. To begin with, we are going to look at some of our keywords from last week. Can you remember any of them? We're going to go through the actions and then play Simon Says. So our first one, we're actually going to start with push. This is an easy one. Show me an action for push. Good job, like you're pushing a swing to move something away from you. Push the swing. The opposite, pull. Show me an action for pull. Like you're pulling the swing back, so they're opposites. Pull, like you're pulling the lid off a pen. Move towards you. Push, move away. Okay, pull the lid off the pen. Push the lid on the pen. Good job. Next one is force, which is a push or a pull that makes something move. That's got three actions. My turn, your turn. Do a push, then a pull, then a move. Good job. Show me force. Show me push. Show me pull. Then we've got magnetic. Do you remember that one? Do you remember I had a hair clip last week? What happened when I used my magnet on it? That's right, it pulled it towards it. So it was here. It pulls it. This one's a very strong magnet. Look, it's not even touching it. Did you see that? Just going to check you can see. Yeah. Wow, it's a strong magnet. It doesn't even need to be touching. We'll find out about that later. So this one is magnetic. So we're going to have our magnet and we're going to be pulled towards it. My turn, your turn. Magnetic. Magnetic. Good job. Next one, attract. Attract is another way of saying that something pulls towards it. So the clip is attracted to the magnet, or we can say the magnet attracts the clip. My turn, your turn. Attract. Show me. Attract. Show me force. Show me push. Show me pull. Show me magnetic. Good job. The last one is repel. So if attract is pulling towards, what is repel? It's pushing away. My turn, your turn. Repel. Your turn. Show me attract. Show me repel. Good job. Okay, Simon Says. So I'm going to tell you a word and you need to act it out. Only act it out if I say Simon Says. If I don't say Simon Says, you have to stay silent. No action. Simon Says push. Did you do this? Good. This is the action. And because I said Simon Says, you did it. If you're in Mrs. Clayton's key worker group, she's going to be looking out for the right actions. Simon Says force. Did you do it? Magnetic. I didn't say Simon Says, but magnetic is this one. But you shouldn't have done it. Attract. Yeah, Simon didn't say. Simon Says repel. Did you do this? Push away. Simon Says attract. Simon Says repel. Simon Says attract. Push. Oh, I hope you didn't do it. Simon didn't say. Simon Says push. Simon Says pull. Simon Says push then pull. Force. You shouldn't have done it, but it's. Simon Says magnetic. Simon Says attract. Simon Says magnetic. Simon Says force. Push. I hope you didn't push. Simon didn't say. Two more. Simon Says attract. Repel. Oh, you didn't need to do it. Simon didn't say. Good job. I hope you've got those words in your head. They'll be useful for today. So today I am learning to explore magnetic forces. Remember, a force is a push or pull making something move. So we're going to see how magnets are a force today. To begin with, we're going to look at different types of magnets. There are other ones as well, but these are the three examples I have today. You might think about the other shapes and sizes of magnets that you have seen. So I'm going to read the three types I have out and then we're going to try and match them. Horseshoe. Like on the bottom of a horse's foot, they have metal horseshoes to protect them. That's a clue for the shape. We have a bar one. And the last one has got three different names. It's called a button magnet, a disc magnet, or a circular magnet. Let me show you my first one. This one's from school. Where does this one go? Horseshoe, bar, or button? You might want to draw and label them. That's right, this one goes in bar. It's a bit like the shape of a chocolate bar. And you can see this one has north and south on it, which we're going to talk about again in a minute. Last week, my magnets like this one, they don't have north and south on them. And these ones have one colour for north and one colour for south. So bar goes with this one. And I've got 2 bar magnets. Oh, what are they doing? That's right, they're attracting each other. Let's put them at a distance. Okay, what about this one? This one I've got from home. We're looking at this bit here. Do we think it's a horseshoe, a bar, or a button, disc, circular magnet? That's right, it's a circle shape, or the shape of a button or disc, so it goes here. And the last one, this is my favourite one because of the shape, a horseshoe one. And this one feels really, really heavy. That one goes here. You might find some other shapes, like there's also a magnet called a ring magnet. Looks a little bit like a hula hoop. It's a ring shape and it has got a hole in the middle, or a bit like a polo. But we didn't have any of those in school, so I've got these 3 as examples for today. So we're going to revise what we learned last week. So I've got 2 magnets today. We did it with pictures last week. I saw some brilliant uploads, but it's much more fun with real magnets. So as you can see, these ones are blue for the south and red for the north. What are they examples of? What are the ends of a magnet called? Can you remember? Pause the video. That's right, they're called poles. We have the North Pole and the South Pole. Every magnet has a North Pole and a South Pole. Even if it's not written down, it will always have both. Do you remember what is special about the North and South Pole? What do they do? So here I'm going to put these 2 together. So you can see I've got North and North. Every time I push them, if you're in school, you can do this, but I have to really, really push to try and get them together. It feels weird. They kind of avoid each other. Why? What are they doing? They are pushing each other away, so they're repelling. So north and north repel. What was the rule I told you about? Yeah, the same poles push away. So if they're the same, they don't like each other, they push away. Which other ones are going to push away? Let's turn them round. South and south. Let me try. No, look, can you see? Do you see how it moved it? It just pushes it away. Let's try that with north and north again. Yeah, they're repelling. They push each other away. So south and south repel. North and north repel. What do I have to put together for it to attract? Repel, push away. Attract, pull together. Yeah, they have to be opposites. We say opposites attract. A bit like your best friend might be very different to you, but you get on really well. So let's turn north and south. What happens? Can you see I didn't even have to touch them? I'm going to keep that one still. Wow, so we had a little gap. So these are very strong magnets because they don't even have to be very close, because magnetism, which is the force of magnets, is very strong. It's invisible. We can't see it. Like a push we can see because it's a contact force. A pull is a contact force. This one, you can't even see it happening. It's an invisible force. And I can do it the other way around. So again, north and south. Did you see? They're attracting and repelling. Pause the video. Which poles repel? Did you get it? North and north repel, and south and south. Which ones attract? North and south, or south and north. Good job. We're going to do something special now. We're going to try and see the force of a magnet. Now, I've said magnetism is invisible, but there's a kind of way we can see it by looking at what it does to other objects. So, I've got this special little container here. It's see-through, so we can see what's happening. It's transparent. And inside, I've got these tiny little grey bits. What do you think they might be made of? They look a little bit like dust. They're not as fine as dust. But when you do this, can you see what's happening? What is the magnet doing? Even though they're not touching what's inside, and this is covered in plastic, so there's a barrier, what's it doing? Can you see? That's right, it's pulling it towards it because the powder inside is magnetic. What could the powder be made of if it's magnetic? Remember, magnetic means something that is pulled towards a magnet. Last time we sorted things into, do you remember? Magnetic like the hair clip and non-magnetic like the sequin, for example. Which materials were magnetic? Oh, I'll give you a dojo if you can message me and tell me. They're not all metals. Do you remember we found that lots of our objects which were made of metal were magnetic. Things like wood and plastic were non-magnetic. Look, non-magnetic, the plastic. So 3 metals: iron, nickel, and cobalt, or cobalt, as some people say. Some other metals are made by combining one of these metals with another. So not all metals are one type of metal. They might be another metal and iron, or another metal and nickel. So any metals containing these 3 as well will also be magnetic. So remember those 3. So what could this be made of inside? That's right. These tiny particles inside are actually tiny bits of iron. They're called iron filings. Your turn. Iron filings. And because they're made of iron, which is magnetic, my magnet attracts them and makes them move around. And even though the plastic's in the way and there's a gap, so you can see it's about that thick, this shows the magnets, the force of the magnet is quite strong. It has to go through the plastic and through the air to attract the iron filings. Now I'm going to show you something really cool. I think it was this way I did it earlier. So I'm going to spread them out a little bit. There we go. Can you see it moving it around? Where is it moving? So I'm just putting it like this. Where is it moving the iron filings the most? That's right, it's moving it here and here, which is where the ends of the magnet are. If I turn it, can you see it's turning the iron filings with it? That's because the poles, or the end of the magnets, are the strongest parts. It's where the most force is. So, for example, the clip will be attracted to here more than here. See, can you see? I can't pick it up. Can you see what happens to the clip? Yeah, I can't pick it up with this side. The pole is the strongest part, so it's that which picks up the magnet. Can you see how it sticks to both ends? There we go. Doesn't stick to the side, it sticks to the ends. Let's try it that way around. There we go, you can see it happening now. Can you see as I turn? It's sticking to this end, and it's sticking to this end. Let's keep spinning it. Spread them out a bit. I'm going to do it the other side as well so you can see. I think that side works even better. Can you see what kind of shape it's making? It's making like a circular shape because I'm spinning the magnet around and the iron filings are getting attracted to the ends of the magnet. So it's like following the ends around. So the strongest parts of a magnet are its poles. Now, hopefully this will work. I have tried it out. I want to show you how we know these repel, how we know these are pushing apart. So I'm going to put these 2 like this underneath. So I'm going to put both north ends facing each other. Watch what happens. Okay, let me... Actually, no, I'm going to put it here. Can you see what happens? Can you see the iron filings? Because look, it moves here. So let me spread it out again. The iron filings are attracted to the end of the magnet. They're not attracted to the south pole because the south pole isn't above the iron filings. It's above the air. It's too far away. But can you see the pieces of metal inside are going to the 2 ends of the north pole? But when I try and put them together, can you see there's a gap? Can you see that little gap here? That gap is where the magnetic force is pushing the magnets away from each other. Because they're both north, they cannot push together, so there's a gap. The iron filings just go on to the very north bit, but not in between. Clever, huh? Let's try with the south. Let's see, there's also a gap. Also a gap. Can you see that they're attracted to the south poles, but there's a gap in the middle Because they're repelling each other, they're pushing each other away. And that's how we can see that magnets repel each other, because of that gap. And I can actually feel it. If you do it with two magnets and their south poles, you can actually feel, I'm not actually moving these like this, they're pushing each other away, and you can see that gap. So what do you think is going to happen when I put a south and north? Do you think I'll see that gap? Let's see. No, we don't see that gap. The iron filings are attracted to the south and north end, but can you see how the iron filings can go? There's no gap. That's because they're attracted to each other. There's no gap. There's no invisible force which is pushing the poles away, because as the poles are pushed apart or repel, the iron filings follow them. Because they're not pushed apart, the iron filings do not follow them. They can go everywhere because the poles are attracted. Let's try this end. No gap. They're attracted to the ends of the poles that you can see, but there's no gap. Let's compare it again to the south. Oh look, attracted to both poles because the poles have a strong magnetic force, but because they push away, that invisible force in between that's pushing them away, you can see is that gap here. Isn't that clever? I think that's a really cool way of showing repel. Let's try this one again. Look, attracted to the north poles, but there's a gap where the force here, the magnetic force in between, that it's pushing each other away, that force. So cool. We call the force around a magnet a magnetic field. So because a magnetic field is quite strong, especially around the poles, so we said it was strongest around the poles. Do you remember? That's where the iron filings are going the most. But things will still be a little bit attracted to the other areas of the magnet. The areas in which things are attracted to the magnet is called the magnetic field. It's the energy all around the magnet. The closer you are to the magnet, the stronger the force. If you go further away, there will still be a force, but it will be weaker. So the area around the magnets, all around here, that you can't see, it's invisible, is called a magnetic field. So it'll be really, really strong around here. And as you get around the edge, it will still have a force, but because you're further away, it will not have such a strong force. Like the clip, really strong here, but I can also attract it from a distance, see? So my magnetic force is quite strong all the way out to here, around here. But if I put it further away, it's not as attracted because the force is not strong enough here. It has to be closer so that the force is more powerful. So the strongest points are around the magnet's poles, close to it, but it will still have a force further away. It's just weaker. Really cool, huh? Science is amazing. I hope you've enjoyed today's lesson. Please complete the quiz now on your portfolio.